All right, so we're going to take a look at this thing called integration with partial fractions. Basically, what integration with partial fraction is when we're dealing with a rational function that we can't use u sub for, we can't use completing the square. Really, none of our methods are working to help us relieve any of the integration issues. Right, so it's just another strategy or another step. So the whole concept of working with partial fractions is by saying, hey, this fraction we have right now is the combination of two individual fractions. So what we do is off to the side, we try and find out, hey, what are those two individual fractions? So we take our 1 over x minus 1 times x plus 2, and we say, okay, well, this is equal to one fraction a over x minus 1 plus another fraction b, some number, right, b or a, we don't know what it is, over x plus 2. So the way that we could work with these is solve for that a and that b. Now, here's the thing. What we're going to do is get rid of the denominator. So we multiply by that common denominator, which would be our x minus 1 times x plus 2. And we'll do that across the board here. So we're going to multiply everything by that x minus 1, x plus 2. When we do that, we end up with 1 is equal to a times x plus 2 plus b times x minus 1. Now, in order to find out what these numbers are, what we're going to do is we're going to come up with a couple let statements, because obviously these fractions have some undefined terms or some values that would cancel each other out. If we want to cancel out the a, we would say, okay, well, let's let x equal to negative 2. And when we do that, we'd have 1 equals a times negative 2 plus 2 plus b times negative 2 minus 1. And we solve for our values. So we have 1 equals, this part zeroes out, b times negative 3. So we have 1 equals negative 3b, where b is equal to negative 1/3. Then we're going to do the same thing, but with the other side, we'll say, let's let x equal 1. And when we do that, we have 1 equals a times 1 plus 2 plus b times 1 minus 1, which zeroes out. So we have 1 equals 3a, and a is equal to 1/3. Right, so in this case, it's just just so happened that a and b were the same numbers but different signs. That won't always be that case. Now, what that means is the equivalent form of this fraction, right, as two separated fractions, would actually just be the integral of a was 1/3, so 1/3 over x minus 1 plus negative 1/3 over x plus 2. And what we would be doing is integrating this whole term. Now, when we do that, we could kind of bring those 1/3s to the front. We would have 1/3 times the ln of x minus 1 minus 1/3 times the ln of x plus 2 after we integrate. And then we have our plus c at the end. That would be our final answer by using this method of integration by parts. All right, let's take a look at another example too. So sometimes you might have more than just those two pieces. So if we're dealing with more than those two pieces, well, first thing we're going to have to do is factor this out. So when we factor this, we would end up with, again, some side work over here off to the side. We'd say 2x squared minus 7 over, when we factor this, it would factor to x times x minus 4 times x plus 1. And that equals, now we just put a variable over each term, a over x plus b over x minus 4 plus c over x plus 1. Again, what we'll do is we'll multiply everything by that common denominator. So we're going to multiply everything in here by x times x minus 4 times x plus 1. And when we do that, we'll be left with 2x squared minus 7 is equal to a. Now we're going to have to write two pieces left over here. So a times x minus 4 times x plus 1 plus b times x plus 1. And then plus c times x minus 4. All right, and we'll do that same thing, but now we're going to have 3 let statements. So our first let statement, we're going to have to say, like, let's let x equals 0, all right, I'm going to go with my first term. So when x is equal to 0, we'd have 2 times 0 squared minus 7 equals, now everything that has just an x cancels out, so the b and the c are gone. And we'll say a times 0 minus 4 times 0 plus 1. All right, so as we solve this, we have negative 7 is equal to negative 4a. So a is equal to 7/4. All right, when we work with b, or our next term, I'm going to just go down this order here. So I started with the x equals 0. Next one I'm going to work with is x equals 4. So we're going to say let x equal 4. So anything with the x minus 4 cancels. So I'm left with 2 times 4 squared minus 7 equals b times 4 plus 1. All right, so we have 16, 32. We have 25 equals 20b. So when we divide that 20 over, we end up with b is equal to 5/4. And then we'll do that same thing. Finally, this time we'll do this with the last term. So we'll work with letting x equal negative 1. So when x equals negative 1, we have 2 times negative 1 squared minus 7. Now everything that has that x plus 1 cancels, so we're just left with c times negative 1 times negative 1 minus 4. All right, as I substitute those values in. So we have 2 minus 7, we get negative 5 is equal to negative 1 times negative 5 is positive 5. So we have positive 5c. When we divide that 5 over, we get c equals negative 1. All right, now what that, again, allows us to do is rewrite our integral. So we could go back to the beginning, and what we're really saying is we're integrating 7/4 over x plus 5/4 over x minus 4 plus a negative 1 over x plus 1. Right, we're integrating each of these terms, each of these pieces. And then, right, all of these have that x in the bottom, so really your ln's pop up a lot here, right? Your integrals are gonna be a lot of ln. So we're gonna have 7/4 times the natural log of the absolute value of x plus 5/4 times the natural log of the absolute value of x minus 4 minus the natural log of the absolute value of x plus 1, and then plus c at the end. And that would be your final answer for this integral. All right, so right, that's your integration by parts. Just kind of keep practicing and working on that process.